Hello, Anna here. We're going to do our last little video lecture to go with the histology unit, and we'll be talking about tissue injury and repair. All right, so when we're looking at the repair of epithelial tissue, of connective tissues, even muscle tissue, we're going to be talking about it in terms of two types, whether it's regeneration or fibrosis. So what is the ultimate difference, the meat of what the difference is? Regeneration, the tissue is like new. It functions the same. Okay? But with fibrosis, it's replaced with a fibrous CT. Okay? This is essentially scar tissue. And functionally, it's not the same. Because it can't be. If you're replacing epithelium with scar tissue, the scar tissue can't do the same thing as epithelium because it's not epithelium. This is also sometimes called stromal repair or fibrosis or fibrotic repair or something like that, okay? Regeneration, basically the reason it's like new is because you replace with the same cell types. Okay. Now part of what helps determine which form happens is degree of vascularization. Okay. And basically things that are well vascularized, all right, I'm just going to abbreviate that, they're more likely to do regeneration. Okay, so this would be like epithelial tissue. Even though epithelial tissue itself doesn't have its own capillaries, it's in the adjacent areolar connective tissue, it still has a really good supply of resources that are coming from the adjacent connective tissue. Bone tissue, adipose tissue, and of course areolar, because it's got all those capillaries, all regenerate pretty well. Things that have weak, let's do weak regeneration. So it can do some, but it's not good at it. So I want you to look at cartilage tissue, okay? Cartilage is also avascular, but because it's a gel, things don't move through it very easily, so it's difficult for it to regenerate. Interestingly enough, skeletal muscle, even though it does typically have a lot of capillaries in it, it also does not regenerate well. And things that do kind of moderate regeneration would be like cardiac muscle and nervous tissue. No regeneration. It is really hard to replace heart muscle cells once they've been damaged. Nervous tissue the same way, so they get replaced with scar tissue. Okay, all right, what I want to do next is kind of go over the steps of repair real quickly on some pictures from our book. All right, so we're going to use skin to describe the basic steps of skin repair, or of tissue repair, and really everything begins with inflammation. So you see here somebody stepped on a nail. All right, they've gone through their epithelium all the way through here. They've gone through the areolar CTP here, and then they've gone down into the, the dense irregular here. When they did that, they tore the tissue sufficiently that you've ripped blood capillaries, and that has caused the tear to fill up with blood, okay? So severed blood vessels bleed. You're also going to be releasing inflammatory chemicals, so that's represented over here by the blue, and this is important because those chemicals are coming from the torn cells that got cut by the stepping on the nail, and then these chemicals migrate, and they're going to stimulate other things to come in, like white blood cells and also platelets. All right, so that stimulates these things to come into this area. While we're doing that, the local blood vessels also become more permeable, which helps to escalate this part even more. And of course, the clotting is going to begin to occur on the surface. And where it dries out, you will get a scab. All right, if it stays wet, we just call it a clot. All right, let's look at the next stage. All right, so the first stage was more about stopping the bleeding and getting the stage set for repair. The second step is you're starting to really do the repair. So organization, restores the blood supply. So we have done some angiogenesis, bringing in more blood capillaries. These capillaries have extended out where you see the blue is. I'm going to erase that so it doesn't cover up what our stuff is. And then here, when we did platelets, when we did the clotting cascade, we also have these little fibers that go in here, would have fibers here and here. And basically those fibers begin to tighten and bring the sides closer together, which basically bridges the gap and narrows the gap, okay? Now, these are neutrophils right here, but this is a macrophage, okay? And then we're also bringing in fibroblasts, which are helping to clean up, produce those fibers. But the macrophage is a phagocyte, and it's going to come in and it's going to start eating away debris, dead things, bacteria, kind of cleaning up that area. And then the other thing that's going to happen as you're doing this, these cells are going to receive chemical stimulus that ups mitosis. And as you do that, you replace the base here, and then eventually it's going to replace up here, and slowly you're going to fill in those epithelial cells. Let's look at the next slide. All right, here we're really cleaning up the area. Now, what I want you to notice is we've basically mostly replaced all of this with functional epithelial cells. So this is regeneration. But down in the areolar connective tissue and densoregular tissue, you will see the remnants of the fibers. So this is scar tissue. This is the fibrotic area. So we did fibrosis more down here and regeneration up on the epithelial cells. And that is because epithelial cells regenerate really, really easily and really, really rapidly. I still have a little divot, all right, because we're still replacing epithelial cells, and we still have this depression, which is also helped created by this area in here. Over time, macrophages will eat out these areas, and they will start to replace some of this. And the same thing over here. We'll kind of clean this up a little bit more, and we're going to add more and more cells in here to kind of push this area up, so that over time the scar tissue here will be replaced. And that might take a few years. It might take 20 years. I don't know if you've ever gotten a scar like when you were 10 and then you're 30 years old and you can't see the scar anymore, okay? Some scars never go away, all right, because they're too big or too extreme. And then other scars can be over a very long period of time regenerated, okay? All right, that was it for tissue repair, so pretty quick and easy. You'll study this a little bit more, the inflammatory process in pathophysiology. It's really neat. It's interesting how it works, so I hope you enjoy that. And I'm going to go ahead and stop this recording.